Hey guys, welcome to week 1-2. We're going to talk about here in this video um, a little bit more about hard drive geometry, a little bit more in depth than we talked about in CFR 101. As you would expect, in 105, we're going to go just a little bit deeper here. And we're going to talk about specifically, you got an assignment coming up due Sunday night. About converting what's called the CHS address, hard drive address, to an LBA address. And there's lots of great stuff out there you can read, and there's great mathematical formulas. If you just plug everything in, it works, and you'll get the right answer. The problem I found, and this is just me, the problem I found with converting using this formula is because maybe I don't have the most mathematical mind in the world. Um, I, it was hard for me to conceptualize what was actually happening by reading a textbook and doing this formula. And so I thought I would show you in a little bit more maybe kinesthetic or visual way how that actually happens, and show you a different formula that to me that I think I made it up. I don't even know if anybody else is doing it. So anyway, I get the right answer. So it's just a little more intuitive, and and hopefully will make sense to you looking at it kind of logically. And if you're a math guy or girl and you like the formula that's in the textbook, if that's working for you, great, keep using it. Otherwise, I'm going to show you this little trick, I guess you could call it. All right, so let's kind of recap hard drive geometry just so we're using the right terms and we're talking intelligently about this. A hard drive, every time. A hard drive, a traditional, legacy style hard drive, not a solid state drive, but a platter based drive. So you got a, say a 5.5 inch hard drive, internal hard drive, and it's got, four spindle, a spindle with four platters on it. These are metal platters that are magnetically coated and encoding. And at the manufacturer, they're going to determine a couple of things when they create these platters. They're going to determine the number of bytes per sector, and they're going to determine the number of sectors per track, and they're going to determine the number of tracks per platter. Okay, and so that's all great. I think we understand now that a track is kind of a concentric circle on the surface of a platter, kind of like an old record player. If you've ever played a vinyl record, most of you are probably too young for that and haven't. But basically, concentric circles on the disk store information, and each of those concentric circles would be called a track. And this track is divided up into little segments called sectors. And then the sectors, of course, are subdivided further into bytes. Usually 512 bytes per sector, although newer hard drives, larger than 2 terabytes, are often sectored into 4096. Is that right? 4096 bytes per sector. I just pulled it off the top of my head because I'm drawing a blank, but I think that's right. Anyway, the idea here is that you need to know, the operating system needs to know by talking to the file system where these sectors are. There has to be like a bitmap of these sectors, or a way to describe a physical location on the disk, so when a file is written to it, you can go back and find it later, right? And when you drop your file into a little desktop folder or something, and you've created a logical file path for it. It's got this directory path. That's all well and good for organizing it logically in your head, but it's actually got to be out there in binary somewhere on a sector on this hard drive, on one of the platters on the hard drive. Now, something that's really important to remember is that the tracks that go around, the concentric circles, okay, there's two corresponding tracks for, and there could be 100 tracks on a disk. I don't know how many typically tracks there are on a disk, but there could be a lot. There could be 1,000. I don't know. I'm not sure. or more. But there's a top surface of the platter, and then there's a bottom surface of the platter, and they both have a track encoded on it, or a series of tracks, and the top tracks and the bottom tracks correspond exactly. They line up, and then the next platter down has a top track and a bottom track. Well, they refer to the top and bottom sides of the platter. Each track on it is referred to as a head, right? Because the head of the the armature that reads the information actually is, it's got a top and a bottom side. So that's why they call the top side of the platter, the first head, head 1, the bottom side of the platter, head 2. Okay, and so if you look at this diagram up here, am I looking the right way? I think it's this way. If you look at this diagram up here, you can see that there are, in this picture, there are 3 tracks just kind of randomly picked out of the middle of the platter, and they all line up on top of each other, corresponding tracks, both top and bottom. So head 1 and head 2 of the track, and then the next disc down is head 3 and head 4. Same track, it's directly under the track on the top disc, top platter, and then the third platter down has also the same track, right? The corresponding track lines up both top and bottom of the third platter. All of those tracks together are called a cylinder. Okay, so I hope that makes sense. It looks like a cylinder. So that's when we talk about cylinders, heads, and sectors. We're talking about physical location on the disk based on that disk geometry. Okay, we don't really use CHS addressing anymore. However, in the NTFS file system, it's still encoded, right? In the master boot record, it's still encoded as, in some cases, a cylinder head sector address. Okay, and so for you and me, we need to know how to convert that to what we would call an LBA, or a logical block address. And the difference, well, before I get ahead of myself, let's finish describing what a CHS address looks like. Okay, so hopefully I can move forward here. All right. I think I covered all of this stuff here. My head's in the way, so you can't read it. Oops. Oh, wow. All right. Let me go over here and move my picture. Not that you even really want to see me talking, but so you can read this here. I'm just basically saying that the number of, I guess it's up here now, isn't it? Yeah, I moved my picture to the other side of the screen. The idea is again, I've kind of covered all this. You have the total number of tracks per cylinder is determined by the number of heads. In this exercise, we're going to refer to this total number of heads per cylinder as THC. I don't even use that terminology anymore, really. It's more intuitive to do it a little bit differently. So let's move forward. Next slide. Okay, so here's an example of a CHS addressing scheme, or an example of a disk. So you've got, now I got to move my picture back over to the other side because I'm blocking it again. Okay. So if we look up here. There we go. Look up here. Follow along with me. We have an example of a hard drive. Let's say it's a huge hard drive, 500 megabytes, right? It's a half a gig, which is actually, really common back in 1993, a 500 megabyte hard drive. And so in reality, that's 526,417,920 bytes. And that's under the schema of 512 bytes per sector. Total number of tracks per platter, so we have just over 1,000 1020 platters per tracks per platter. So when I was talking earlier about the concentric circles on the platter, in this case, this disk has 1,020 per platter, those concentric rings. It says total heads is 16 heads. That tells me that there's possibly 8 platters in this disk, right? In this hard drive, there's 8 platters, and that, each one has a top and a bottom, so there's 16 heads. And then the total number of tracks per sector is sectors per track, I said that backwards, the total number of sectors per track is 63. So if we wanted to find out, again, if we want to figure out, well, how do we get this 500 megabyte drive? How do we get 526 million bytes? How do we figure that out? Well, we just take the total number of um, cylinders or tracks per head, right? So those concentric circles, we're talking about cylinders. How many of those are? Well, there's 1,020 of those, and then we're going to multiply that by the total number of heads, right? The top and the bottom. So each side has 1,026 tracks. So you get one platter has 2,040 of them, right? The top and the bottom. And then if you've got 8 of those, then you would multiply 2,040 times 8. Well, in this example here, we're saying take the top side, 1020, and multiply that by the total number of heads, top and bottom, which is 16, and that would give you the same number. And then you multiply that by the total number of sectors per track. Okay, so you multiply all that together. It's just 1,020 times 16 times 63, and that gives you a total of 1 million sectors, a little more than 1 million sectors. And then if you want to find out the total number of bytes, you multiply that 1 million sectors times 512, because that's the number of bytes per sector, and that gives you your hard drive capacity of 526 million bytes. Okay, so again, a really simplified, very small drive just for comprehension purposes. You can kind of wrap your head around these numbers, even though it's unrealistic. You'll never find a 500 megabyte drive anymore. But just conceptually, just for demonstrative purposes here, we've got this very small hard drive. All right, so what's next? Basically, we're going to take that first track, and we're looking at it right now, and we're saying, okay, that first track has, if we're looking at just the diagram up here, we see 3 platters, a side view, a top view of the platter, and then a side view of 3 of the platters in the stack. And we know that there's actually probably 8 platters. We don't have all 8 of them drawn. We only see 3 of them there. But for that first cylinder, we can see the blue is represented on top of each platter and bottom of each platter. We're going to pretend like we could actually visually see that track for that cylinder. So there's the cylinder for 3 platters. In reality, it actually goes down, probably 5 more platters, right? So there's a total of 8 platters, top and bottom of each. That gives us 16. All right, but we have a CHS address of 4-3-2. Now, you remember the schema is 1020-16-63, and that's telling us, that's created by the manufacturer, that there's 1020 total cylinders on the disk. So if we were looking at this top view, right, looking down on the circle, we would see, right there on this drawing, it's very simplified. There's like 1, 2, 3, 4, 5, 6, 7 tracks or something, right, which is kind of silly, but it's just for visualization purposes. The diagram has 7 tracks, but in reality, this hard drive has 1,020 tracks. So they're very small, microscopic. The human eye probably wouldn't be able to discern them, right? There's in a space, this big, the radius of the disk, there's 1,020 tracks there, right? So the picture is obviously not to scale. And then you look at the side view, that cylinder, right, has 16 heads. The picture only shows 6 of the heads. It's only showing 3 disks, but if all 8 disks were depicted there, you would see that continue down for 5 more disks. There'd be 16 heads. And then if there's 63 tracks per sector, that gave us that 500 megabyte drive, right? And so what CHS address schema is showing us here is it's saying we are looking at and this is just an arbitrary disk location. We're just saying there's a file located at CHS 4-3-2. And all that's saying is we're going to take the first 4 cylinders, okay, and then we're going to go down 3 heads, right, from the top. So on the next cylinder out, so like on the 5th cylinder, well, it's not the whole cylinder, it's just the first 3 heads or the first 3 tracks from the top down, and then 2 additional sectors. So that's the physical address of this file, this hypothetical file that we're talking about is 4-3-2. So it's 4 full cylinders. So from the outside, from the inside out, we're going to go 1 cylinder, 2 cylinders. Here's the 3rd cylinder, and then here's the 4th cylinder. So 4 full cylinders all the way down to all 16 heads. Does that make sense looking at the picture over here? So if you've got all 16 heads and 4 full cylinders times 16 heads times 63 sectors per track or per head, and that would give us a really useful number. That would give us the total number of tracks represented by just this 4 value, this 4 address. That's the cylinder address. So we're going to take all 4 cylinders times 16 heads or 8 discs and multiply that by 63 sectors per track. And that gives us a total of 4,032 sectors just in that first part of the address, right? Just in the cylinders. We're just adding the cylinders, the sectors for those 4 cylinders. We're calculating that, okay? So now we know in those first 4 cylinders we've got 4,032 sectors. Okay, so now we just have to add on the next 3 tracks of cylinder 5, right? It's not a full cylinder, it's just the next 3 tracks of cylinder 5 and then 2 more 2 more sectors, okay? So again, this is redundant. Sorry about the slow animation here. And in reality, should have drawn 1 more track up there, okay? Because what we need to do is we need to take that the 3 heads from that last track, from that 5th track, or from that 5th cylinder, just take the top 3. So if you're looking at the picture, I think you can see my mouse here. So out here, we're going to go out to the 5th track, so about right here. We're going to take the 1st head and the 2nd head and the 3rd head. Now all 3 of those tracks, all 3 of those heads for that 5th track are part of this address. So we're going to take all 3 of those, and it's 3 tracks, and there's 63 sectors per track. So we're going to multiply 3 times 63, and that gives us the total number of sectors in those 3 heads. Okay, so we got 189 sectors for this second part of the CHS address. Remember how many we had for the first one? It was like 4,032 sectors, and now we've got 189 sectors for the second part of the address, and now we just have to add the last part, the last 2 sectors, which of course is a no-brainer. And here goes the animation again. Sorry, I apologize for that. But really what we need to do is just add those 3 numbers together now. 4,032 sectors plus 189 sectors plus the last 2 sectors. And that gives us a total sector count, right? So this file that we're hypothetical file that we're addressing as 4-3-2 starts on the 4,222nd sector on this massive 500 megabyte hard drive, okay? So that's useful information, but now we have to convert that over to LBA, and there's just one more step that we have to do that because, yes, okay, the 2, right? Got it. All right. So, sorry, there's the animation again. LBA, the LBA address schema just basically starts at the very first sector on head number 1. So the very first platter, the top surface of that platter starts at the very first track at sector 0 on the very first track and goes around and then jumps to the next one and keeps counting. It just keeps counting, right? So by the time you get to the end of the top head of track 1, if we had did we do the math for that? If we had let's pull up the calculator. I'm a little brain damaged tonight. It's like 10 o'clock. Sorry. So here's our calculator, right? And so if I have 10, 20 tracks per sector, per platter head, right? So on the top surface of the first platter, I have 10, 20 tracks, and I know that there's 63 sectors per track. I know that on the top surface of the top platter, so head 1, I've got 64,260 sectors. Okay, so yes, that should be correct. Yeah, all right. And that's the total number of sectors on the first platter, right? And so a logical block address would go just from the middle out to the very end to the last sector on that platter, and you'd have 64,000, sectors on that first one, and then the bottom side would have 64,000 sectors, so it's 128,000 sectors for the first platter and 128,000 sectors for the second platter, all the way down to the eighth platter where you should have, 500, 500,000 bytes, right, worth of sectors. All right, so uh, the logical block address just starts at 0 and keeps counting sequentially through each platter. It doesn't start over with each platter. It just continues. The first sector on the next platter starts in that continuation, right? What was the number? Did I close the dang calculator? Doofus, yeah, I did. But anyway, it would just continue with the next sector in sequence. Okay, so in order to take this CHS address of 4223 and convert it to LBA, we just have to subtract one sector. Why? Because LBA starts at 0, right? So it's 4,222. Sector 4222 is actually the 4,223rd sector in sequence, but its number is 4222 because we start counting with 0. So that should be clear as mud, and that conceptually is how you convert a cylinder head sector to a logical block address. So when you do and I wanted to do this lab because some of you turned in this lab early, and I looked and you didn't have the right answers. And so I wanted to make sure that I gave you this concept of what you're really doing. If you're just plugging numbers into a formula and it's not working, okay, I'm not sure why it should, but this is how you actually would conceptually calculate the physical location on disk. If you had the CHS address of 432, you would convert it to LBA and you would come up with 4,222. So the LBA address is 4222. Okay, so anyway, hope that helped. Hope that helps you with the lab. It should. And good luck. Text me or email if you have any questions, and I'll try to get back to you as soon as possible.